blending models. And it's really interesting because the aggregate models, when we were doing those last time, they're very tedious, I mean, it's just there's more places for mistakes, there's a lot of rows, and it takes you a little while to get through it. But conceptually, there's nothing about it that is, strange, that that really is that hard to wrap your mind around. And so it's just getting through the, all the way through it and being really careful as you do. So the blending problems are kind of the opposite of that, because they're often kind of short with respect to what you have to, formulas and functions that you have to put in. It doesn't really take that long to do that. But what you have to understand is how the blending constraint itself works. And that takes a little bit of time to wrap your mind around what's happening with that. And so that's where the conceptual side of it might be a little bit more difficult. So kind of the first thing you need to know is what is it that a blending model is doing. In a blending model, and you're putting things together, okay? You're combining things, you're combining ingredients, you're combining, in one of our problems, crude oil to make different levels of crude oil to make gasoline and heating oil. You're combining, we're gonna have a really unconventional one, but anyway. So you're combining stuff to reach a particular level of an average quality level or an average something that you're looking for. And it's because you're blending these things together to get that's what makes the blending problem. So you'll see this as we go through it. Our first one is a little bit unconventional though, in that what we are blending is people's skill and years of experience for a particular job. So we run this little recreation company and we have these trails and we need trail guides for them. And the trails there's three of them, the easy, the moderate, and the extreme. So some of the things that factor into this is that we pay the trail guides differently based on their years of experience and their skill level. And that formula is right here. You can see how much we pay them additionally for years of experience and skill level. We had 45 people come in to apply for these jobs. But we only need 6 people on the easy trail, 4 on the moderate trail, and 3 on the easy trail. So what we're going to do is try to hire people in such a way that we will minimize our payroll costs. I mean, we could hire the most experienced people, but we would be sort of over-hiring for the easy trail, and we don't really need to do that. And so instead, we want that's actually going to be our goal or objective function, is to take that weekly payroll and minimize it, okay, get it as low as possible. What we need to know about the people that we need to get is what we're requiring from them as far as years of experience and skill level. But what makes this one a blending problem, is when we say the easy trail requires an average, okay? An average of 1.5 years of experience and a skill level of 3. So what we didn't say is that anybody that works on an easy trail has to have at least a skill level of 3. We didn't say that. We said on average we have to have a skill level of 3. So it'd be perfectly okay to hire someone with a 2 and someone with a 4 and know that on average we had reached our 3 skill level. And that's what's making this a blending problem. If we didn't say that, this wouldn't be a blending problem. If we just had a minimum requirement, it wouldn't be a blending problem. Okay? But we do. And here are the years of experience and skill for each of the 3 trails. The 45 applicants came in with different levels of years of experience and skill and different quantities of each of these groups. So we laid it out in these categories, these types A through L, of what their experience and skill, and this is how many applicants came in of each of those types. So we're gonna need that information, and it's gonna be on the worksheet. As soon as we solve it to figure out which, how many people from each type level do we hire for each trail, okay, as soon as we do that, when we're done with that, then we're going to do a little bit of, what if analysis. This first one's a little bit different because the question says at what years of experience and skill level for the extreme trail does the model become infeasible? So the point in this one is a little bit different than our normal solver table where I'm trying to get you to get an answer and analyze, why it's like this. It's more about I want you to see something that happens when solver gets stuck. And so anyway, we'll look at this one. Then we'll answer the next one, approximately how much does each additional moderate trail skill level cost the company? Okay, we'll answer that. After we're done with that, we'll go to one that's a lot more traditional, conventional looking, and it is a textbook example. So all the information is in the textbook that you'll see on the worksheet in a minute. But it's example 4.4 regardless of which edition you have, but it might be on a different page regardless, in the different editions. But anyway, so either way, it's example 4.4. But after we run solver on that one to figure out how much gasoline and heating oil, how much crude oil to put in, make, everything, we will do the sensitivity analysis that you see here, these two different ones. And these are really, really straightforward sensitivity analysis questions, the kind that you might would see on an exam, because every piece of information is all laid out. It's not the ones where we want to talk about what parameters it ought to be. Everything's very well laid out in those. All right, let's start with the first one first. There's the trail guide model. It's got a lot of stuff, got to look at what all the different pieces are. But for one, this is what we're asking the solver to do for us. We're asking solver to put people into these positions from these different types into these 3 different trails. Okay, that's what we're trying to get Excel to do. But those numbers are constrained by the fact that you only had a certain number of A's. So whatever Excel tells you to hire here, it can't be any more than 10. Okay? Whatever Excel tells you to hire for J, it can't be any more than 2. So that's important that we constrain that, but we also have to make sure that on every trail, we get the amount of people that we needed. So we have to at least get 6 for the easy trail, 4 for the moderate, and 3 for the extreme trail. Okay, so that stuff has to happen. And then of course, remember, we could just say, hire the best people, but that'd be very expensive, and it would be kind of overkill on the easy trails. So that's why that's our objective, is to minimize the total payroll, but in order to figure out the weekly pay and the payroll for the week, we've got to know the pay rate. So we'll fill that in. But all of this will be pretty straightforward, as far as what we need to do. Then we will get to the blending constraints. And in the blending constraints, what we have to make sure of is that we get the years of experience that are required, and that we get the skill that's required. And we're gonna really have to talk about these when we get to them, okay, and how we accomplish that. But let's start with the easy stuff. The easy stuff first, okay. For one thing, we've got to calculate how many total people Excel tells us, because remember, Excel's gonna be filling all this in. How many total people does Excel tell us to hire from type A? And the reason we have to figure that out is so that we constrain it and we don't let it tell us more than 10. But what do we do right there to figure out how many people we hired of type A?
Some of the easy, moderate, and extreme.
Yeah, just sum up the number that were hired on each of those 3 trails. Okay. And that's gonna be the same thing all the way down. And probably not one we have to do a lot of spot checking on, but we can do it anyway. All right, so we have calculated that so that we can constrain that. How do we calculate how many were hired for the easy trail?
Sum of the A to L easy trail.
Same idea, sum all of those, and then you'll know how many were hired, because that has to be constrained to make sure that you hire as many as you need. I'll check it, but it's all good. All right, before we can do the weekly pay, we've got to do the weekly pay rate. And all that is a matter of getting that formula into this cell. So that formula is they pay them $300 plus $15 for every year of experience plus $25 for every skill level. Those constants are right here, the 300, the 15, the 25. So basically we just have to get all this in here. So the 300, the V3, I'm gonna quick press F4 and make it an absolute reference to it, because everything that's on row 3 has to have, well, it has to have a dollar sign at least in front of the 3. You don't have to have it in front of everything, but it at least has to be in front of the 3 so that when we copy later, it'll be there. So there's the base plus $15 times years of experience. S3 times S6, the S3 will be the one that's absolute, plus the $25 times the skill level. So the formula is V3 times, I'm sorry, V3 plus S3 times S6 plus T3 times T6. And anything that's on row 3 at a minimum has to have a dollar sign in front of the 3. You have it both, it's fine. And then the things on row 6 don't.
Do you have to like make sure to put it like in parentheses or something?
No, because the mathematical precedence order of operators is that multiplication would happen before addition anyway. But with that said, it does, I'm just really bad about not doing it because I know how things are gonna, how things are gonna calculate. But it doesn't hurt to do that kind of stuff to make it look really clear when you're working on it. So it wouldn't hurt to do that, just to make it more clear to somebody else that picks it up and looks at it. So a type A person would make $365 a week, whereas a type L person would make $585. Pretty big difference there. So if you don't have to have the more expensive people, don't hire the more expensive people. Don't only hire what you need. Because you're in charge of a little business and that's how that works. You're gonna be trying to not spend more than you have to. Okay, so for the weekly pay for type A people, that calculation would be what? The total number of people you hired that were type A, and then multiply that by the weekly pay rate. So I don't know how many it's gonna tell you to hire, but however many it tells you to hire, you will be paying each of those people $365. So the E6 times the V6, that doesn't need absolute references. Just copy that down. And I think that you also could do this one pretty quickly too, and that's that the total for the whole week for all the people that you hire, just sum up that column. Just sum up I6 to I17. Now, that's the way we did this, but that's the way this model was created, to have that sort of extra in there, because it didn't have to. You could have skipped this whole step, and you could have gotten the number here by doing what? What was that? Just do a sum product of this and this, because that's what you did anyway. You took the product, you summed them. So people choose to structure models differently. If you decide to expand it, if you decide to condense it, well, that's up to you. That's how, when you come in and there's a shell already there, you just sort of have to fill in what, you're supposed to fill in. But when you're creating them for yourself, you can choose to expand or condense as you see fit. But that could have been done without doing this, just by putting a sum product there. It wasn't, but it could have been. Okay, so that's the straightforward stuff first. Now we're gonna get to the, let's do it this way, the blending constraints, and kind of start with, the first thing I want to start with is us figuring out how many total years of experience did we obtain by whatever it is Excel tells us to hire. Okay, how would we know how many total years of experience we obtained? How would we calculate that? Just in general, what would we do?
Total skill, no.
So let me just give you a little scenario. I'm not gonna worry about the fact that we need 6 employees. Let's just say it told us to hire 2 Bs and 2 Hs.
Some product?
Yeah. Because if it told us to hire some number of things here, for every one of those, a B for instance, we hired 2 of them, well, they'd each have a year of experience, that'd be 2 years of experience. They told us to hire 2 Hs, Hs would have 3, well, there'd be 6 more years of experience. See, so the sum product, obviously we don't know what it's gonna end up telling us, but the sum, Okay, I can't type. My hands are freezing in this room. We need to know what Excel tells us on the easy trail to hire. We need to know what the years of experience would, what the years of experience would be for those. And I'm gonna press F4 on that one so that I can get it. Okay, I got a lot of things in here I didn't mean to get. Let me try that again. There. Oh, I see what it is. I just can't read. All right, that and that. Again, for every 1, 2, 3 of these, you get that many years of experience. I want this one to be relative, I want that one to be absolute because I'm about to copy it across, okay? Because I want to do the same thing for the moderate and the moderate and the extreme trail. And I mean, on this one, I would do a little spot checking kind of thing, make sure it's giving me extreme trail, it's giving me years of experience. Now, this is in total how many years of experience I have obtained with whatever Excel tells me to hire. And so I'm going to go ahead and put that exact same kind of calculation in here for the skill level, okay? Because it would be the same idea, the exact same idea. How many total skill levels, I don't know what you want to call it, how much total skill level did I get? I do it the same way, the sum product the easy trail, how many it tells me to hire, and then what the skill level is for each of those types. Okay. Same idea. Those two ranges, I'm finding those two ranges. This one's relative, that one's absolute, so that I can copy it. Go over here. Okay. So here's the thing about figuring out what you got. You figure out what you got because you have to make sure it's what you need, okay? You've got to accumulate what's your total, skill level that you got from these hires or years of experience, because you have to make sure that it matches what the requirement is. So here's how you were told the requirement. You were told that the requirement was that, we'll just start with the easy trail, that on average you had to have 1.5 years of experience for the easy trail. So what you just calculated, or what we just calculated in B23, is the total years of experience on the easy trail, but what we obtained, because we do it for everyone, so. So you just see the total years of experience that we obtained. We just figured that out in B23, C23, D23, the 3 different trails. That needs to be, I need to make sure that that meets my 1.5 years of experience for the easy trail, 1.5 years of experience on average. So what would I do to be able to compare that? What would I do with my total years of experience to get an average to compare it to the average?
Divided by the total hire?
Yeah, and you were gonna say the same thing, right? Or did you have a different question?
No.
Okay, so when you're trying to get an average, you're taking a sum over a count. That's what an average is, a sum divided by a count. Here's the sum of all the total hours of experience that we obtained. So the sum of all the, not hours, years. And we divide it by the number of people hired. And we know that that has to be greater than or equal to what we were told was the average years experience that was required. Okay? So that's what we have to find out. Because that's what we were given. We need 1.5 years of experience. We need to make sure that on average we got that 1.5 years of experience for the easy trail. The problem is we can't enter this into our models without it messing our model up. We can't have a division on one side of the inequality of one of our constraints, okay? We can't. There's a number of different reasons. Cause some linearity problems. It will cause problems if ever this number, in the course of whatever different problems you had, if that was ever a 0, then you would be trying to divide by 0. So we cannot have the division on one side of the inequality in our constraints. Okay. So, we still have to answer that question. We still have to make sure this happens. But what could we do to get rid of the division?
Multiply.
Multiply what?
Number hired.
Yeah, multiply both sides by the number hired. Which then gets rid of this and leaves you with your total years experience obtained has to be greater than or equal to your average, oops, somebody, average years experience required times your number hired. That's the way we have to put it in. Is that exactly the same thing as that? Yeah, I mean, it is algebraically manipulated, but this is the same as this. It's making the same thing happen. It's making sure that you're getting what you needed, okay? But it's doing it without a division on one side of your inequality. And so we have just calculated total years of experience that were obtained. Now we need to compare it to this side of the inequality. And we're gonna do that right here in cell B25. We're gonna find the total. See, what's happened is we've changed from comparing the average to the average to comparing the total to the total. That's what has to happen to make this work, okay? So now we wanna know, in here, then what do I put in here as the calculation for my total required?
B26 times
B26, which is the average required, and then
the total hired.
multiply by total hired. Okay. That's B26 and B19. That's what it is. So that's the side of the inequality I'm putting in here. Now, what did I know? What was specified? What was specified was this 1.5. Okay, but I've got to get everything into totals. Everything has to be in totals. And so that won't need any absolute references. I can just copy that across. And I would do the exact same thing for skill, right? I mean, take every place over there that I have years experience and change it with skill level. Okay, and it would be the exact same thing. Okay, I need to compare totals to totals, and so therefore I already have the total skill level. I need to compare it to the total skill level obtained. I need to compare it to the required total skill level, which would be taking the average in B31 and multiplying it by how many people we hired. Okay. So same idea. The right side of that inequality. That doesn't need any absolute references.
Would you put in total skill level?
Total skill level is the sum product, just like the, just like we did on the years of experience, but like who do you hire, and in each of those levels, you know, what would their skill level be? So that's the sum product of those two things. And of course, in the first cell, I make sure that one's relative and absolute so that I can copy it over. Okay, so sometimes, you know, there's a few extra things that you put in here, but the bottom line is on a blending problem, this actually has two different things, but I end up with two blending constraints, yeah.
For total required, would it be possible to do some product of like that red row and time, like comma 1.5?
I don't know if we could just put a constant in there for it. Cause like in a
I mean,
sum.
not, like, you could just put like cell,
So you're typing like one of these, like pick one of these total required cells.
yeah, and then equals some product, that whole red row above it, and then.
This
comma,
one?
Yeah,
Okay.
then comma.
And then put a comma and then.
Average required, or required average.
Try it, but I don't think you can do that with an extra thing there. I don't think that it'll take a single cell. See, that's the problem, like if you listed it all out, but I don't think it'll take a single cell. I'm trying there is essentially say total hired, which is
Yeah.
what that is. Okay, and then if you do this, I just don't think that some product will like this, but we'll find out. Yeah, cause some products expecting its ranges to match each other.
Mhm.
It's not, you know, if you had an entire range somewhere, I guess, that had those numbers in it, you know, that might be different, but then on the flip side of that, isn't that more complicated really anyway? You know, if you could do that, you know, if you had 1.5, so I think it would be more complicated to do, so. Okay, it's all filled in at this point. It's got its blending constraints. This one just happens to have 2 blending constraints that go with it, but you're ready to solve. Our objective is what?
I-19.
Yeah, it's I-19 and we wanted to minimize it. We want to minimize our total weekly payroll. By changing, well, we can kind of tell what those are, but it's how Excel assigns types of work, the number of, you know, each type of worker to each trail. Okay? So that's B6 to D17. We add constraints that say what?
Total hired is less than or equal to the number of applicants.
Yeah, so the total hired here has to be less than or equal to, of each type, has to be less than or equal to the applicants that came in each of those types. And so that's E6 to E17, less than or equal to G6 to G17. What's another one?
Total hired has to be greater than or equal
Yep.
to needed.
So then you've got the total hired for each trail, that number, which is in B to D19, and that has to be greater than or equal to what you needed on each trail, which is in B to D21. So that kind of takes care of the total hires by type, the total hired by trail. Okay, and what's another constraint?
Years of experience.
Yeah, you start now you've got the blending constraints, the one for years of experience, the ones for skill. So first starting with the years of experience one, the total you obtained, B to D23, greater than or equal to the total, not average, but the total that was required in B to D25. Then add the one for skill, which is basically the same thing. The total skill level you acquired, B to D28, greater than or equal to, not the average, but the total skill level that was required, which is in B to D30. Okay. On this problem, because the nature of the problem, you kind of, I guess, have to know what they want to do, but if they want to hire all full-time employees, then it is a good idea to do what?
Integer.
Make this integer. That isn't always the case with blending problems, because a lot of blending problems aren't working with blending people, okay? But, you know, in this particular case it is, and if you want them to all be full-time workers, then you can set all those changing cells to be integer values. That's B6 to D17, make all of those integer. So what you end up with, besides the fact that you're minimizing I-19, minimizing costs, you end up with, you know, this changing cell range being integer, a constraint that makes sure you get everybody that you need for each trail, that you get all the years of experience, that you get all the skill level, and that you don't hire any more out of any given applicant pool than you have available to you. Okay, so once you've got all those constraints, everything's set up, Simplex LP, when you go to solve it, so you should end up with a total weekly payroll of $58.25. Did anybody end up with that, but they have something different up in the number of people they hired from each type? Like instead of 3 on the first level, it's like 2. I don't remember what it is. I've seen this solved before where it still comes up with $58.25, but it's some slightly different combination. it happens, and I don't know. I can't seem to recreate it, but I know that it can happen. Okay, so that's the solution. It doesn't suggest you hire any more than you absolutely needed. Why would it? I mean, it's a cost minimization problem. Why would it do that? You know, you don't want to incur any extra costs, so it doesn't. You basically just kind of meet right at what you need. You know, you get like a slightly higher here, but that just ends up like that. Okay. So when we get it, we'll carry the concepts of this blending constraint into the next problem. But before we get to that, there are a couple of little sensitivity analysis things to do. And one of them is more about you seeing some stuff that's gonna happen. And it's the first one, and it says, at what year's experience and skill level for the extreme trail does the model become infeasible? So we need to go into solver table, to run solver table, and it does ask you to do both. The years of experience and the skill level on the extreme trail, to mess with both of those. So it is a two-way table. And I'll just put both of those in, where one of the inputs is D26. That is the required average skill level for the extreme trail. I'm just gonna try to put this in here in a different way. Extreme, oh, that wasn't skill, I'm sorry, it's years of experience. Extreme years experience required. Yeah, you abbreviate it however you want, but that is the years of experience, average requirement for the extreme trail. So that's one of them. The other one's gonna be D31, which is the one I said a minute ago, the average extreme trail skill requirement. Just kind of getting some name in there. But we are gonna be varying these two, okay? I know I don't have parameters on the PowerPoint, but follow me on this one, because you don't want this one to get much bigger, because it's already not gonna run all the way through it at this. But I'm taking the years of experience one from 3 to 5 in 0.5 increments. Okay, I'm gonna take that D26 from 3 to 5 in 0.5 increments. I'm gonna take D31 from 7 to 9 in increments of 1. Okay, sure, I don't wanna do any extra here. I didn't name an output cell. But to be honest with you, this doesn't even ask a question in a way that you would even know what you should do as an output cell, because basically it's just asking when does it become infeasible. So what you choose as output doesn't matter at this moment, because that's not what's the result of what we're trying to get out of it. But I am just gonna choose the weekly payroll at I-19. I'm just gonna choose that as my output cell, because it really isn't, the output cell isn't what matters right now. All right, everybody got that in there? The D26 going from 3 to 5 in half increments, D31 going from 7 to 9 in 1 unit increments, and then you can look at I-19 as this goes in. So when you run solver table, and you can watch it, and it's just buzzing along here doing what will eventually be thousands of subproblems. Sometimes it goes really fast, sometimes it goes a little bit slower, and then there are times when it's never gonna stop, okay? It's just gonna keep going and going. And I don't know if I say never, but I've never been patient enough for it to stop. I don't know if it was ever gonna stop or not. And that can happen, okay, that can happen. We haven't done anything wrong in this model. This model is right, it's correct. We chose parameters that are making this not wanna finish solving, okay? So you're sitting there the day of the test, and this happens, but we'll have a word about that in just a second. But this happens to you ever. You're working on something for real, you're practicing these problems, whatever it is. To eventually get this thing to stop, you press escape, okay? And then you click stop, okay, to get it to stop. There we go, it took it a minute. Sometimes you have to do that more than one time. Escape, stop, escape, stop, escape, stop. Sometimes that happens. It depends on how many cells it got hung up on. Okay, it did not get hung up on these just because they say not feasible. It's just clearly telling you these aren't feasible. clearly telling you what the optimal weekly payroll is for each of these combinations, but do not ever finish that cell right there. And it says solver was stopped at user's request. If you had something that was a little bit bigger and there were several of these cells, that's when you would have to say escape stop, potentially multiple times to get yourself out of this. So what do we know about that? Not much. I mean, as far as why is that not coming to a conclusion, I'm not really sure why it's taking such a long, long time. I'm thinking at some point it was eventually gonna be infeasible, but I'm not really sure. But what I do know from the results that I get is which things are not feasible. Okay, I can see that. So we're currently at 3.5 and 7. We're right here. We could step up our years of experience to 4 and, you know, stay with the skill level of 7, and that'd be it. We couldn't go any higher. We could, if we wanted to, drop back to 3 on our years of experience and bump up to 8 for a skill level, but nothing past that. So we're at the edge of what we can do here. Why are we at the edge of what we can do? Why aren't these things feasible? What's the reason that it can't do those? Yeah, I mean, it's all about, you know, in my first 2 classes I had people saying, well, it was gonna cost too much. Well, we didn't put a cap on the payroll. We didn't ever say we have a budget and we have to stay within it. So if we were gonna be willing to basically pay whatever it took, our problem was we didn't have people that came in at those higher levels, or enough of them that we could end up filling if we wanted to have years of experience for skill level 8. Can't do it. Okay, so that's the reason. That's why it became infeasible. But the most important thing about this, I do want you to see what happens when it's going on and on and on, and you think it's never going to stop. Why? Because it could happen to you when you're studying. It could happen to you in a real problem. It could happen a lot of times. It should not happen to you on the exam. I don't have one that does this on the exam. And if it does this to you on the exam, and it will, to somebody, somewhere, not you, be somebody else, okay, but if it happens on the exam, you press escape stop, you call us, we'll tell you to press escape stop, okay? We'll get you out of it. But what that means, because I just told you there isn't one like this on the exam, that means go back to the model and look at your formulas, look at your solver setup, look at your solver table setup, look at everything, because something's wrong. Okay, that's just, I'm just telling you, don't sit there and think that I'm you know, because we did it in class once, that I'm doing this for the exam. I'm not. Okay, I'm not doing this on the exam. So go back and fix whatever it is, because it shouldn't happen. But for reality's sake, you know, it could happen to you. Like there's nothing wrong with this model and this happened. So I'm not saying it's, you know, I'm saying on the test it will mean something's wrong. Not always.
Could you show the input and outputs for the solver table reading?
Yes.
Because I didn't get that solution. Mine was a little bit different.
Yeah. So on solver table, that was what I had. The inputs were D26 and D31, which were years of experience and skill on the extreme trail. Then I did the 3 to 5, and I know they're not on the PowerPoint, but I did 3 to 5 and half, and 7 to 9 and 1 increments. And then I just looked at I&IT. It really doesn't matter what you choose as the thing you want to look at, because we didn't really have a specific question that went with the output. Did you get it?
Yeah, I mean, mine's the same as yours. So,
Let me look at it.
I think I got it now.
Okay, I was gonna say, let me look at it after. And then the next question that goes with the trail guide stuff is, approximately how much does each additional moderate trail skill level cost the company? Okay. So we're gonna run a solver table, and it's asking us to vary what? When the question said, how much does each additional moderate trail skill level cost the company, what are we varying?
Can you repeat it again?
How much does each additional moderate trail skill level cost the company?
Skill levels for
The
moderate
moderate trail skill level. And that's the only thing it's asking us to vary. So that's it. So it's just a one way. And And that's it. Where is that one? That one is right there. Okay, so that's C31. It's the only thing it asked us to vary. And I know that it asked me to vary that because it asked me how it impacted something else. It asked me how that impacts cost, okay? So, what is that? Moderate skill required for, anyway. Okay. I don't have parameters on here, so I'll tell you these just real quick. I just decided to have it go from 3 to 8, kind of that's up and down from where we are now, in steps of 1. It'll give us good output. So, go from 3 to 8 in steps of 1. And I kind of already said this, but what is the output?
Wages?
What was that?
Wages?
Yeah, that payroll, that weekly wages, whatever you wanna call it, right there in I-19. Because it's saying to us how much does varying that cost. You know, how much does each additional cost? So the answer is in the cost of it. And so that's C31 going from 3 to 8 in steps of 1, looking at I-19 as the output. It's not a very big solver table, it shouldn't take too long. Okay. When I wanna know how much additional something costs, I'm always gonna be doing my little subtracting one thing from another thing. I mean, that's how I get that information. If I was, and I'm not, but if I was at 3 and I bumped up to 4, it would cost me $65 more. If I happened to be at 5, if I was 5 and I decided I wanted it to be 6, that would cost me $125 more. If I was 5 and I decided I wanted to bump it down to 4, I'd save $85. Okay, so this, you know, the question on a test would have to be a little more specific with exactly what it is you're looking at, but and we'd have parameters and everything in it. But that's the cost. I mean, the way this one asks it, you might think you should just do an average, which you could, which would be perfectly fine. It's $87.50, but it might be more specific. If I wanted to bump it up one level, if I reduced it by a level, how much would I save? Well, I would save $85 if I took it from a 5 to a 4. Yeah.
I actually have a value for the 8.
Oh, you do?
Mine-
Okay.
I don't, is there, I did everything the same as you. I don't know, maybe
So I'm
it's-
thinking there's something, because you just asked about something else that didn't come out exactly right. I'm thinking there's something in the model that's slightly not right.
What is the total that you estimated?
So if you went back over here, so one way to test this, if you go back over here, well, I mean, yours is working when there's an 8 there, but it shouldn't. Like if I put an 8 in here and I ran solver, I shouldn't get a solution, okay? I mean, according to my solver table, I shouldn't get a solution. And so somewhere, I think there's some little thing wrong in yours, because it should tell you you can't bump that all the way up to 8.
Because I have the same total that you have in,
Uh-huh.
I have the exact same thing, but my weekly pay looks a little bit more, so. Is that possible to get like the same solution, just?
Basically, you're saying that these numbers are different.
Yeah, and also my weekly
I've
pay.
seen that happen before, but then the rest of it still worked fine, so that makes me think there's something somewhere that's not quite right.
Is, if you can go back to the solver table, is
Right.
that 8 not feasible something that's gonna happen to us in the exam?
Oh, yeah, that could happen. But not feasible is not a not working.
Right.
Is not a not working thing. No, I might actually ask a question just like that, only it just wouldn't be one that stalled out, you know, and I wanted you guys to see how to do the escape and the stop and all that stuff. But I might actually ask a question where, you know, when is it not feasible, when is something not feasible? You know, when can't you do this? And then you would look for when it's not feasible. Yeah.
Thank you.
Yeah, that can work. Okay. You know, to continue with the understanding of the blending, for instance, not just these solver tables, we take a different turn with Chandler oil to be a very, traditional looking one, a lot more conventional looking model. And it just, I think it just helps solidify what it is you're looking at when you're doing blending. It's also actually really small. And so it'll help us with some of the results being more or less intuitive and easy to spot check things and say, oh, I think that this makes sense. So here is the information that you would see, if you were looking at the book problem, and that's that you were trying to make gasoline and heating oil by combining crude oil 1 and crude oil 2, which have different levels of quality associated with them. Okay? You sell the gasoline and heating oil for $75 and $60 a barrel respectively. The quality level in crude 1 is 10 quality points per barrel, we'll kind of call it that, and the quality level of 2 is 5 quality level points per barrel. But it turns out that the heating oil, yeah, I was gonna do the gasoline first, but anyway, the gasoline needs 8 per barrel, and the heating oil needs 6 per barrel. Okay, that's an average, right? Okay, so we know the whole thing. You're given numbers typically in averages, and then later when you're doing blending constraints, you have to make them totals. Okay, but that's per barrel has to have 8, per barrel has to have 6. What we're gonna ask Excel to tell us is how to input crude 1 and crude 2 in order to make these two different things, with a constraint that we don't have unlimited crude 1 and crude 2, we have limitations on that, okay? That we have to meet our quality constraint, we have to get what we need, okay? With this one's overall objective being to maximize revenue, okay? So that's the overall objective in this problem, is to maximize revenue. So that's what we've got, okay? Now we'll kind of start filling some things in. We have to figure out how much crude 1 and crude 2 we use because we don't have an endless supply of it. So what would we do there in D16? What do we do to figure out how many barrels we used? Yes, we sum them up. This was the easy stuff, remember? This was the sum the rows, and well, I'm not even gonna say it, I'm gonna wait and see. Okay. Let me tell you something real quick before I ask you what goes in here. There is an assumption in this model that the number of, that the input barrels will equal the output barrels, okay? So if you put a barrel of this in and a barrel of that in, you're gonna have 2 barrels of whatever your output is. Is that reality on how this stuff is really made? I'm not sure, but it doesn't matter, because for this model, your inputs and your output barrels will be equal, okay? So that's the one thing to know. Now, I could call this barrels made/sold, because basically there's another assumption there, is that whatever we make, we can sell. There's nothing about demand in here, there's nothing constraining that, how much we should make. If we have enough input to make it, they'll buy it. If we make it, they will buy it. Okay. So how do we figure out then how many barrels are made/sold? What do we do of gasoline? Yep. We just sum that up. So again, just so you start getting some patterns going here on what's happening, you're always gonna sum the rows and the columns. You just are. Always gonna, these problems are gonna sum the rows and sum the columns. I mean, there's a reason for that, because we're comparing it to things, or we need it for something else, but then that brings us to the blending constraint. Obtained. What do we do in the calculation to figure out how many total quality points we obtained for gasoline? What would the calculation be? Okay, I have a question. If we produced 2 barrels of gasoline, 1 barrel of crude 1, 1 barrel of crude 2, how many quality points would we have?
15.
We'd have 15. If we did 2 barrels and 2 barrels, we'd have, so what'd you just do? So what's the calculation? It's a sum product. Excel's gonna tell you some number of crude 1 and crude 2 to put into the gasoline, okay? For every crude 1 barrel, you're getting 10 quality points. For every crude 2 barrel, you're getting 5 quality points. I'm gonna make that one absolute. Not that it's a big deal when I'm only copying over one more cell, I can probably just type it again, but it's those two, okay? Then I'm copying it. You could just retype it if you don't wanna do relative and absolute. And then, of course, the same thing would be true of heating oil. For every barrel, I get 10, for every barrel this, I get 5. Okay? So that's my total obtained. That would be the total I obtained. Now I need to compare that to the total that's required. Now that's the total that's required. What would I do there?
Some product of the required and the
It's not a sum product.
We multiply the barrel soil, so the barrel we soil with, we multiply for the quality decline, meaning
Yeah.
the 80 and 60.
Yes, yeah. So in other words, if we end up selling 10 barrels, how many quality points in total did we need?
80.
80.
Because that's what we did. What you just said is what we did. However many of these barrels we make/sell, they each have to have 8. And so that one is just multiplying the, the 2. So B18 times B12. That doesn't need any absolute references, and I'll just copy it over and check it, but it's a pretty straightforward one. Last but not least, revenue. What's the revenue?
Is it barrel sold times the selling price?
Yeah, the barrel sold times the selling price, which, because there's 2 of each of them, because it's gonna be the sum product of that. The selling price. So that's what revenue always is, right? It's always selling price times units sold. Okay, so it's selling price on each of the 2 products, the amount sold on each of the 2 products. That's it. So you see actually how small the model is with respect to putting formulas and functions into it? I mean, you think about the aggregate, it like took a whole class just to get all the formulas in there and get them copied across with the right relative and absolute addressing. And that's not the case here. And some of it's really easy. You sum the rows and you sum the columns. But when you get to that blending constraint, you really have to stop and think, what am I putting into this blending constraint? I'm putting totals. I'm putting total obtained being greater than or equal to the total required. But you gotta think about what those formulas are and what gives you that, what gives you those 2 totals. And then usually you then have an objective cell as well. But we're ready for solver. What's my objective?
Is it maximize revenue?
Maximize revenue. So revenue's in B27, I wanna maximize it. And I do that by changing how, I make gasoline and heating oil, and of course it requires that I plug these different, raw materials into it, these 2 different things. So it's B16 to C17, how I plug these in to get my total number of barrels. And I add constraints that say what?
Barrels used less than
Barrels used have to be less than or equal to what I have available to me, so that's just a pretty straightforward, resource kind of constraint. And then what else?
Do you want us to put an integer or?
So that's a great question. I kind of mentioned when we were doing the trail guide one, that we put the integer in there very specifically because we were working with people and we wanted them to be full-time and all of that. Most blending problems, it's not necessary to put integer constraints into them because it's not necessary to think that you had to do entire barrels or excuse me, that you had to if you have ingredients with gallons or pounds or this or that. It's usually the more conventional ones are things that it would be perfectly fine for you to be using a portion of it, okay? And so there's not really any reason to think on most blending problems that you have to have integer constraints. And so we don't have anything in here that, you know, if you looked at the book problem and all that stuff, that tells you that, you know, that they want you to use whole barrels. So no, actually most blending problems won't have integer constraints in them. So what is our one other constraint?
Quality points.
Yeah, the quality points, which is your blending constraint, your B22, C22 being greater than or equal to B to C24. So you actually only end up with just those two constraints. You just, you
What
know,
about
you're
an
maximizing
integer
B27.
constraint?
What was that?
Integer constraint or no?
No, that's what we just talked about. On
No.
blending problems,
No,
it,
okay.
for the most part, isn't necessary to have integer constraints, because you're not usually dealing with things where it matters. Now, it was in the trail guides, but usually you're not. Usually it's combining ingredients in pounds and gallons and barrels and things that it doesn't matter if it's, you know, if it's something other than that. But so you just have the two. The resource constraint, the blending constraint, that's it. That's it. Now, with that said, this is your textbook, and so your textbook always makes sure that these came out as integer no matter what. Okay, we're not that good on the exams, we don't spend that much time. But, you know, but I usually do on the exam tell you if do or don't use an integer constraint, and most blending problems you wouldn't. But ours probably don't end up all nice and round numbers like this. They work hard at that. So, this is small enough that when you look at the results of this, there are some things that should just look right to you. And I say that because if they looked wrong, that's when you want to then revisit your formulas and your solver setup and your solver table setup and all that stuff. It's like you should look at this and go, yeah, that's right. For instance, this breakdown of how much crude 1 and crude 2 that you put into gasoline should look right. Because if that was not, and okay, so I'm not saying you should know these exact numbers. I'm really not saying that. Okay, I'm not even thinking you know the exact numbers.
Excuse me.
But if that was, for instance, if you looked at the result and that was 50-50, I don't care what the numbers were, 50-50, half crude 1, half crude 2, could that even be right? What if you had a product that was half crude 1 and half crude 2, what would its quality level be? If it was half crude 1 and half crude 2, it doesn't matter what quantities, it was half and half. What would the quality level be?
7.5.
What was that?
7.
No,
It'd be
7.
7.5. Maybe average quality level would be 7.5. Okay. You know that this one has to be 8. So you know that you have to have a little more crude 1 than you do crude 2 in this. You don't know the exact numbers. I'm not saying you're gonna know the exact numbers, but I'm just saying if that number was smaller than this, or it was the same as this, that should just flag you right there. This is a small enough problem that you should look at that and go, something's wrong, okay? This has to be a little more than this one. And not a lot more, you know. I mean, it could be, but it doesn't have to be a lot more. Then you look at something like this, the heating oil, and you say, wow, the heating oil, crude 2, we could almost make all our heating oil from crude 2, but not quite, because it's 5 and we need 6. And so there's a really good chance that what's gonna happen is we're gonna use a lot of crude 2, but that we're gonna have to throw some crude 1 in there to bump it up from that 5 to that 6. Again, and I expect you to know the numbers. It's not that, but this should look kind of intuitively obvious as well, that's what ended up happening with these. You know, unless we had just an excessive amount of something to work with, but, okay. I know someone wants to say about that one. But the PowerPoint sensitivity analysis, solver table questions, really straightforward. They're the kind you would see on a test because they have everything in the question. Like the first question says this: vary the price of gasoline from $50 to $90 in increments of 5 to see the impact on the barrels of the 2 commodities that are sold and the revenue. Okay. Everything you need is there. You know, what's the input, what's the output, what are the parameters? It could not be laid out any more concisely really than it is right there, okay? Because it said to vary something, you know it's the input, okay? So vary the price of gasoline, and it gives you the parameters. To see the impact on, if you're looking at how it affects something, the impact it has on, what happens to, whatever follows that is the output, okay? I mean, that's the thing you're looking to see, how varying that input changes this other thing, right? And it just so happened that there were three things they want you to check on: the quantities of these two commodities and the revenue. Because those are gonna be output, I'm going to name the cells. So I'm gonna take V18 and I'm gonna call it gasoline. You could certainly give it a longer name. You could type better than I type. Okay, so gasoline, I'm gonna call C18 heating oil, heating underscore oil, and I'm gonna call cell B27 revenue. So, on the first test, I made you name cells, because I knew that you needed to, and I wanted it to be easier for you to interpret your output. I don't think I make you do that after this, and you're gonna have plenty of solver tables on, the second test. I don't think I'm gonna make you, I don't know, I don't remember, I haven't looked over what we're gonna do, but anyway. I very well may not have you name cells, but you should name cells. I mean, it helps you when you're looking at the output to decipher it, interpret it, answer questions from it. It just makes it a whole lot easier if you named them. But anyway, we're doing it here. So we named it, and we're gonna do a solver table, following along from what that just said, which was to vary the price of gasoline. That's a one-way table. That's the only thing it asks you to vary. So vary the price of gasoline, the selling price of gasoline. That's in B4. So selling price of gasoline. For some reason I can't type, so my fingers are frozen. Okay, B4, selling price of gasoline, tells you exactly what to do. 50 to 90 in steps of what, 5? Okay. 50 to 90 steps of 5, that's given to you on the PowerPoint. And then what you're wanting to look at is how that impacts the barrels of each commodity and revenue. So as output cells, I'm gonna put in there B18, C18, B27. Those are my 3 output cells, which I named, because I think it's a good idea. So vary B4, selling price of gas, 50 to 90 in increments of 5, and look at those 3 outputs. So here are the results, not startling by any means. Right now, you sell heating oil for 60. Okay. Gasoline, which is your higher quality requirement anyway, okay, when it sells for 50 or 55, why would you try to make that one? You know, the one that needs the higher quality level and then would sell for less? Okay, why would you do that? You don't. Okay, you don't. You pour all your 15,000 barrels of input into making heating oil, you make $60 a barrel, and that's how much money you make. So this one's interesting. So now all of a sudden when gasoline is $60, so they're both $60, why does it shift us over to make 5,000 gasoline and 10,000 heating oil? Could have just kept making 15,000 of heating oil, and guess what? We'd make the exact same amount. Well, it happens in solver solutions that there's more than one set of changing cells that results in the exact same objective, you know, optimal objective value. Okay, so because both of those would end up at 900,000, they both would. Why does it choose to do this one instead of just leaving it? I don't know. In this little solution algorithm, did it come to this one first, and so it just put them in here? Maybe. Or maybe it came to it last and it put it, I don't know, okay? Because either one of them would have been fine, okay, but that's what it chose to show us. But after that, okay, after you get to that point, now you can sell gasoline for more than you were selling heating oil for. Of course you're gonna make gasoline at that point because you're selling it for more, and the whole objective in this one is to maximize revenue. So you make more money Interestingly enough, though, this split, this 5,000, 10,000 split never changes. Because you really don't have enough of that crude one, that higher quality crude one, to make any more than this. I'm sure you would if you could, because you sells for more, so you would if you could, right? But you can't, 'cause you don't. Okay. So you don't have it. But that kind of really leads into the next question, which says, what if we did have more crude one available? What would we do then with respect to the breakdown on everything? So that's a good question. Maybe this lower level of crude one's kind of holding us back here. All right, let's go in and look at that. Now they have us vary the availability of crude one from 2,000, which is less than we have right now, all the way up to 20,000, which is a lot more than we have right now, in steps of 1,000, to see the impact on the same three things, the two commodity levels and the revenue. So let's go back into this one. The only thing that we're changing, varying, is the availability of crude one. So it is a one-way table. We're gonna have to reset everything, or get rid of everything that's there, except, don't get rid of this, because those are give you the same output cells, so don't get rid of those. Just get rid of everything else. Leave the output cells, because it's the exact same three output cells that it wants to see in this one that we saw in the last one. But this time, we're varying the availability of crude one, that's F16. Crude one available. And it told us on here, go to 2,000, that's less than we currently have. Go up to 20,000, that's more than we currently have, in increments of 1,000. So from the PowerPoint, go from 2 to 20,000 in steps of 1,000. We're varying F16, the availability of crude one, that's the higher quality one, and still looking at the same three things, the commodity levels and the revenue. When I run this one, big bunch. Okay. So this is crude one that's available to us. When you start out with just 2,000 barrels of crude one, you don't really even have enough high quality crude to make gasoline. It chooses not even, remember what it's doing, it's optimizing revenue. So I'm not saying you couldn't make it at all, but it's optimizing revenue. It doesn't make sense to make it. You don't have enough of it to make. And it doesn't even use all 12,000 barrels of input that you even have, okay? But as soon as you get up one step further than that, you get up to 3,000, you do start making gasoline, okay? You do start making some gasoline. As you increase crude one, gasoline increases, heating oil decreases the whole entire time. You eventually get to the point where you no longer make heating oil if you had 15,000 barrels or more of crude one. Why would you just shift over and make all gasoline?
Because it makes you more money.
It sells for 75 and the heating oil is sold for 60. Okay, so as much as you could make gasoline, you would. Because there's nothing in this model that takes into account costs or anything else. It just doesn't. It's just solely based on revenue. Now, to some extent, there's obviously a lot more you'd have to think through, because that availability of crude one isn't like free, okay? So there would be costs associated with that, and then you'd really have to look at everything. They didn't do that because this was the very first blending model they show you in chapter 4. And so what they're trying to get across in this blending model is how blending models work and how blending constraints work and what goes on. So they weren't really pushing this past that to get at some detailed analysis of, you know, the costs and the profit levels and everything else. They weren't, okay? They weren't doing that. And so when I'm pretty sure maybe even these aren't in the textbook, that we probably just threw these in extra. But that is, you know, that I want you to see very straightforward solver table questions, what they look like. One way, obviously, are a little bit easier to deal with than two-way are with respect to answering questions. But But it does make sense, again, only looking at revenue, okay, that you would make more and more gasoline, because that's the one that sells for more per barrel than the heating oil does. So it just makes sense that you would do that when you had the higher level crude available to you. And that's kind of the end of all the little extras. But before you know you would ever even get to the solver table, you do need to understand the blending model. And this is a very conventional looking one, and you really need to get that blending constraint and how you're comparing the total obtained to the total required. Okay, and this was just a very unconventional way of looking at the same thing. But both of them are good. Both of them help you to understand blending, and then from that, you know, in any problem that we're gonna be doing the rest of the time, we're gonna do solver tables. Just, you know, we're just gonna run different solver tables just to do analysis after the fact. But that's the end of what we're doing in chapter 4, aggregate blending. And next week is chapter 5, and that's transportation and assignment problems. They're very similar to each other. The structure of them is very similar. So we'll do that, and that'll be next week. See you there.